This is the final part of Isro-Vssc Technical Assessment previous year question paper with detailed solution. The exam held in 2021. Post number is 1425. Up to question number 60 we discussed in the last 3 videos. So consider question number 61. A rocket flying at Mach number of 2 has the velocity of approximately, answer is option B, 2470 km per hour. For an object moving through a fluid, such as an aircraft in flight, the Mach number is equal to the velocity of the object relative to the fluid divided by the velocity of sound in that fluid. One speed of sound is equal to 1234.8 km per hour. We must by heart this number. Given Mach number is 2. Therefore, the velocity equal to 2 into 1234.8. So, we get an answer of 2469.6 km per hour. The approximately the answer is 2470 km per hour. Question number 62. A piezo-resistive pressure sensor gives an output of 6 millivolt when excited with a 5 volt. If its sensitivity is 2 millivolt per kPa, the pressure measured is answer is option B, 0.6 kPa. Piezo-resistive strain gauges are among the most common type of pressure sensor. They use the change in electrical resistance of a material when stretched to measure the pressure. These sensors are suitable for a variety of applications because of their simplicity and robustness. They can be used for absolute gauge, relative and differential pressure measurement in both high and low pressure applications. The basic principle of the piezoelectric pressure sensor is to use a strain gauge made from a conductive material that changes its equivalent resistance when it's stretched. The strain gauge can be attached to a diaphragm that recognizes a change in resistance when the sensor element is deformed. The change in resistance is converted to an output signal. Here given sensitivity equal to 2 millivolt per kPa and V out equal to 6 millivolt and V in equal to 5 millivolt. We know that sensitivity equal to V output divided by V input into pressure. Therefore, after rearranging, we get the pressure equal to V out by V input into sensitivity. Substitute given values in equation 1, we get pressure equal to 0.6 kPa. Question number 63. The output of a flow meter based on electromagnetic induction has answer option A, variable frequency. Electromagnetic flow meter is basically used for the flow measurement of slurries, sludges and an electrically conducting liquids. This is the figure of an electromagnetic flow meter. It consists of basic pair of the insulated electrode on the opposite side of a non-conducting, non-magnetic pipe which carries the fluid for fluid measurement. The pipe is surrounded by an electromagnet which produces a magnet field around it. The EMF E induced is given by E equal to BLV, where B is the magnetic flux density, L is the length of conductor, V is the velocity. By means of this principle, velocity or flow is measured. It is also used for the measurement of bidirectional flow. Question number 64. A current carrying semiconductor kept in a magnetic field develops a voltage proportional to the current. This principle is used in option D, Hall effect sensor. Hall effect is the movement of charge carriers through a conductor towards a magnetic attraction. When a current carrying conductor is placed in a perpendicular or transverse magnetic field, then at the edges of the conductor an EMF is developed. This potential difference is called a Hall effect. The arrangement for the Hall effect is shown in the figure. When a current carrying conductor is placed in a magnetic field, the positive and negative charge carriers get accumulated on both sides of the conductor and can measure the EMF by a voltmeter. Applications of Hall effect sensor: speed detection, proximity sensing, that is in smartphones, current sensing application, position sensors, that is example to measure the fuel level in the fuel tank in automobiles, spacecraft propulsion, used as magnetometers to measure magnetic field, that is compass used in smartphones. And question number 65. An analyzer that works on the principle of mass to charge ratio of ion is option D, mass spectrometer. A mass spectrometer separates ions based on their mass to charge ratio. The mass spectrometer is a device which measures the mass of various components of a sample within the sample. For this, the device ionizes each species in the sample and then based on their mass to charge ratio. Question number 66. The following is not a candidate material for laser source in fiber optics. Answer is option D, phosphorus. Laser, light amplification by stimulated emission of radiation. Lasers have found wide application in areas as diverse as optical communication, medical surgery, welding technology, entertainment, electronic equipments, etc. It is used highly because of the collimated nature of the laser beams and the consequent possibility of delivering a very high energy density in a limited region of space. Depending on the material used for the active medium, lasers broadly classified as conventional or gas lasers, solid state lasers, liquid lasers, and semiconductor lasers. Gas lasers. Among the gas lasers, some of the most commonly used ones are helium neon laser, carbon dioxide laser, and argon ion laser. Solid state lasers. Example, ruby laser and ND glass lasers. Ruby lasers consist of ruby, which are Al2O3 with about 0.05% of chromium with a highly polished mirror at one end and a semi-transparent mirror at the other end. Question number 67. A 5-volt voltage source has 50 ohms internal resistance. It transfers a maximum power of, answer is option C, 125 milliwatt to 50 ohm load. The maximum power transfer theorem for DC circuits state that when the load resistance RL equals the Thevenin equivalent resistance across RL, maximum power is transferred to the load. When RL equal to RTH, maximum power is transferred to the load. The maximum power is given by Pmax equal to VTH square divided by 4 RTH. Given that VTH equal to 5 volt and RTH equal to 50 ohm. Substitute these values in the maximum power equation. That is VTH square divided by 4 RTH. We get the answer is 125 milliwatt. Question number 68. In a PN junction diode, the forward current, answer is option B, varies exponentially with the voltage. The current equation for an ideal PN junction with a V voltage forward bias is given by I equal to Is into e raised to V by Vt minus 1, approximately equal to Is into e raised to V by Vt, where Is is the reverse saturation current, V is the applied voltage, and Vt is the thermal voltage, usually at 26 millivolt in room temperature. Therefore, in a PN junction diode, the forward current varies exponentially with the voltage. Question number 69. Write logic function represented by the given K map. A bar denotes the complement of A. After grouping, we get the first grouping is the orange one. Hence, in the column wise, the elements are changing, so don't consider. In the row wise, we get C bar. After consider the first two element grouping, A bar into B bar plus the second grouping A into B. Question number 70. A PSK based digital communication system uses phase shift values of 0 degree, 45 degree, 90 degree, 135 degree, 180 degree, 225 degree, 270 degree, and 315 degree to represent different symbols. The phase of a 90 MHz carrier is changed at the rate of 1 million symbols per second. What is the information throughput involved? Answer is option B, 3 Mbps. Here, the system uses phase shift values of 0 degree, 45 degree, 90 degree, 135 degree, 180 degree, 225 degree, 270 degree, and 315 degree to represent different symbols. That means 8-bit PSK. Baud rate defines as the number of symbols transmit per second, also known as symbol rate. For M-array PSK, it is given as baud rate or symbol per second equal to bit rate divided by log 2m. Given baud rate equal to 10 raised to 6 per second and m equal to 8. We know that baud rate equal to bit rate divided by log 2m. After rearranging, we get bit rate equal to baud rate into log 2m, that is 10 raised to 6 into log sorry, not log square, log 2 of 8, which will get 3. We get bitrate equal to 3 Mbps. Question number 71. What is the Hamming distance between codes 11001011 and 10000111? Answer is option B 3. Hamming distance is a metric for comparing two binary strings. While comparing two binary strings of equal length, the Hamming distance is the number of bit positions in which the two bits are different. Hamming distance can also be calculated by taking XOR of two code words. Given code words are 11001011 and 100011. After XORing, we get an answer of 01001100. The number of ones in the XOR result is 3. Therefore, minimum Hamming distance is 3 only. Question number 72. The address bits A15, A14 and A13 of a microprocessor are connected to a 3 to 8 decoder with outputs designated as Y0 to Y7. The output Y1 of the decoder is connected to chip select of an 8K into 8 RAM. The number of address lines required are option D 16. Given the address bit are A15, A14 and A13, decoder size is 3 to 8 with output Y0 to Y7. RAM size is 8K into 8. To address 8K into 8 RAM, that is 2 raised to 3 into 2 raised to 10 into 2 raised to 3 memory location. The address lines required are 16. Question number 73. The RMS value of the current waveform shown in below is answer is option A 0.5 Im. The RMS value of current waveform is IRMS equal to root of I square m divided by 2t into integral 0 to t sin square omega t d omega t. Square LHS and RHS, we get I square RMS equal to I square m by 2t integral 0 to 2t sin square omega t d omega t. I square RMS equal to I square m by 2t integral 0 to 2t 1 minus cos 2 omega t, not cos omega t, cos 2 omega t divided by 2 d omega t. I square RMS equal to I square m by 4t omega t minus sin omega t divided by 2 limit is 0 to t. Here t equal to pi. Therefore, I square RMS equal to I square mt divided by 4t. Substitute the values. We get I square RMS equal to Im by 2. Here the given waveform is a half wave rectifier output waveform. Therefore, RMS value of half wave rectifier is Im by 2 and average value of half wave rectifier is Im by pi. Question number 74. If A is a 2 into 2 matrix and determinant of A is 25, then what is the determinant of 5A? It's denote determinant. Answer is option C 125. Given determinant of A equal to 5, K equal to 5, N equal to 2, where N is the order of the determinant. From the properties of the determinants, we know that determinant of Ka equal to K raised to N, not to K raised to N, K raised to N determinant of A. Here N equal to 2, so substitute the values, we get 5 square into determinant of A, which is equal to 5, we will get 125. What is the area of triangle having vertices 2,7, 2,3 and 5,3? Answer is option A 6 units. Given vertices of the triangles are 2,7, 2,3 and 5,3. The area of the triangle, the general equation is 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. By heart this equation for future use. Where x equal to y equal to the vertices of the triangle. Substitute the values of x and y. Therefore, area of the triangle we will get 1 by 2 into 2 into 3 minus 3 plus 2 into 3 minus 7 plus 5 into 7 minus 3. That is 1 by 2 into 0 minus 8 plus 20. We get answer as area of triangle is 6 unit. Question number 76. Slope of the normal to the curve y equal to x square plus 2x plus 1 at 1,4 is. Answer is option A minus 0.25. The slope of the tangent to the given curve y equal to f of x at the point P is given by f dash of x. Slope of the normal to the given curve y equal to f of x at the given point P is given by minus 1 divided by slope of the tangent. Given curve y equal to f of x equal to x square plus 2x plus 1. Differentiating with respect to x, we get f dash of x, that is dy by dx equal to 2x plus 2. Then the slope of the tangent to the given curve at x equal to 1 is given by f dash of x at x equal to 1 equal to 4. Then the slope of the normal to the given curve at x equal to 1 is given by minus 1 divided by slope of the tangent. Therefore, slope of the normal equal to minus 1 divided by substitute the value of slope of the tangent 4. We will get the answer slope of the normal as minus 0.25. Question number 77. The probability of student A passing an exam is 2 by 7 and that of B passing is 5 by 7. If these probabilities are independent, what is the probability that only B passes the examination? Answer is option C, 25 by 49. Consider P1 equal to probability of A, which is equal to 2 by 7. That is probability of A means probability of A student A passing an exam. P2 equal to P of B, which is equal to probability of B passing the exam is 5 by 7. Therefore, Q1, that is probability of A not, which is equal to probability of student A not passing the examination equal to total probability is 1. 1 minus probability of A, which is, we will get 1 minus 2 by 7, which is equal to 5 by 7. Similarly, Q2, P of probability of B dash, that is probability of student B not passing the exam, which is equal to 1 minus probability of B, which is, we will get 1 minus 5 by 7, we will get 2 by 7. The question is probability of only B pass. Only B pass means student A fails, and the probability of B pass. Probability of student A pass, A fail is Q1, and only the probability of student B pass is P2. Therefore, probability of only B pass equal to Q1 into P2. Substitute the values of Q1 and P2, we will get, that is 5 by 7 into 5 by 7, we get answer of 25 by 49. Question number 78. The conjugate of the complex number 10 angle 45 degree is answer 10 angle minus 45 degree. Given Z equal to 10 angle 45 degree, we know A angle theta equal to, can also written as A cos theta plus J A sin theta. Therefore, we can write here 10 angle 45 degree as 10 cos 45 degree plus J sin 45 degree. Now the conjugate is Z conjugate equal to 10 cos 45 degree minus J sin 45 degree. Therefore, we can write Z conjugate equal to 10 angle minus 45 degree. Question number 79. The volume of a cube is increasing at a rate of 3 cm cube per second. At what rate is the surface area increasing when the length of an edge is 12 cm? Answer is option A, 1 cm square per second. Rate of change always defines as a differentiation of quantity with respect to time. Given dV by dt equal to 3 cm square per second and x equal to 12 cm. We know volume of cube V equal to x cube. That is equation 1. Differentiate equation 1 with respect to t, we get dV by dt equal to 3x square into dx by dt. Substitute the value of dv by dt and x in the equation 2. We get 3 equal to 3 into 12 square into dx by dt. Therefore, after rearranging, we get dx by dt equal to 3 divided by 12 square into 3. We know surface area of a cube S equal to 6x square. Differentiate equation 4, that is surface area of cube with respect to t, we get ds by dt equal to 12x into dx by dt. That is equation number 5. Put equation number 3 and value of x in equation number 5, we get ds by dt equal to 12 into dx by dt equal to value of x equal to 12 and dx by dt equal to 3 divided by 12 square into 3. After solving, we get ds by dt equal to 1 cm square per second. The last question of this video, also this section, is 80th one. The general solution of the differential equation y dx minus x dy equal to 0. Answer is option A, y equal to cx. Y dx equal to minus x dy equal to 0. That is y dx equal to x dy. We can also rearrange as dy by y equal to dx by x. We know that dy by y is log y and dx by x equal to log x. After rearranging, log y minus log x equal to c. We can also write log y minus log x as log y by x, which is equal to c. Simplify y by x equal to e raised to c. That is y equal to a constant into x. Thank you.